All right, example 4. I know that UQ is parallel to VR. So UQ is parallel to VR. And I know that UP is congruent to RP. So UP is congruent to RP. All right, so what can I infer? Gosh, there's a lot happening. So let's look at, well, I'm going to use this parallel line information first. So if these two lines are parallel, and again, I have a hard time seeing things, so I'm just going to draw it over here, and here's my transversal, and I've got a triangle here and a triangle here. Then I'm going to call these two angles congruent because they are alternate interior angles. So angle U is congruent to angle R because of alternate interior angles. Alright, so I have an angle and a side. Oh, I see I have some vertical angles. So angle UPQ is congruent to angle, let's see, UPQ. So U has the one angle marker, so I have to go over here, RPV. And I used vertical angles. Alright, so now I have two angles and a side, and I see that the side is in the middle, so it is angle, side, angle. So I'm ready to conclude that triangle UQP is congruent to triangle RVP, and that is angle, angle, side, angle. So my proof should say UQ is congruent to, parallel to VR. It's given. UP is congruent to RP, also given. And then I made some inferences that angle U is congruent to angle R. They're alternate interior angles. And then angle UPQ is congruent to angle RPV. And I know that because they're vertical angles. And lastly, triangle UQP is congruent to triangle RVP because of angle, side, angle. And this is a rotation. And I know that because I see the angle 1 marker is over here and then it's over here, so it has to have rotated. If it were reflected, then these would be marked congruent.